Welcome. In today's video, we will learn how to identify even and odd functions. We will identify them graphically and we'll identify them algebraically. Let's go ahead and tackle the first problem. This says determine whether the function is even or odd or neither from the graph. Okay, so this is my x cubed plus x. Before I go ahead and jump in how to identify, let me go ahead and talk to you about what even and odd functions are. So for an even function, to determine if a function is even or odd graphically, let me take a basic example of an even function, which is x squared. A function is, let me move this slightly here. Okay. A function is said to be even if the function is symmetric along y-axis. Now, what do I mean? If you look closely here, my y-axis is kind of dividing this function exactly into half. Or if I flip this part of the function along y-axis, I will get exactly the other part. It is symmetric along y-axis. So if your function is symmetric along y-axis, it is an even function. That is graphically. Now let me talk about odd function. I'm going to take my handy dandy odd function, or the basic odd function, which is x cubed. This is my function x cubed, and you can see that my y-axis is not dividing it. So this is something, the origin is something that's dividing the function. So what's happening with this function is this function flips along y-axis and then flips along, let me use a different color here, and this flips along. So this is flipping along y-axis. The first one was flipping along y-axis. Now I'm flipping along x-axis, and let me show you. When I flip along x-axis, this is what happens. I get back the function. So function is said to be an odd function if the function is symmetric along 0, 0, which is your origin. So technically, when you flip this function along x-axis and y-axis, you get back to this function. So a function is said to be odd if it is symmetric along the origin. And that is your odd function. Now let's go ahead and take a look at the first question. X cubed plus 3. So in my Desmos, sorry, what was the function? X cubed plus x. So in my Desmos, I have x cubed plus x. And if you look closely, this kind of mimics the function of x cubed, and I flip this along x-axis and y-axis, and I get back my function. So definitely this is an odd function because this is symmetric along the origin, right? I'm going to go back, and this is an odd function, different color. This is an odd function. Now you can say, Miss, what if I don't have a graphing calculator? How can I go ahead and see if it's an odd function? Let me show you a simple trick. What's the power of this? X cubed. What's the power? 1. And if you see, 3 and 1 are odd numbers, so the function is an odd function. Now let's go ahead and look at the next one. X squared plus 7x plus 1. Let's use our trick here and see even power. I don't see a power. Power is 1. There is no x. That means x to the power 0. So if I look closely, 2, 1, and 0. 1 is even, 1 is odd, and the other one is even. So when I have a combination of evens and odds and odds and evens, the function is neither even nor odd. So it's neither. Let me go ahead and graph this for you. So here I'm going to graph, it's x squared plus 7x plus 10. And if you see, the function is not symmetric along my x-axis or along my y-axis or my x-axis or my origin. So it does not satisfy any of them. So this function is neither even nor odd. Let me give you a quick example of other functions. Let's just say I have a function f of x is equal to x squared plus x power 4. Both the powers are even, the function is even. Now let's take another example. X cubed plus x power 5. Both the powers are odd. The function is odd. Let's take another example. Now you should be coming up with examples too. Let me make this a little bit darker. I have x squared plus x cubed. So one is even, one is odd, so the function is neither. Now let's go to Desmos, and here I have plugged in some functions. You see both are even. This is a function of x squared plus x power 4. This is a function of x cubed plus x power 5 plus 4. So if the functions are even, then you will see symmetric along y-axis. If the functions are odd, then they will be symmetric along origin. Now let's go back to the question here. What's the next one? They said determine algebraically if a function is even or odd. So for this, let's go ahead and see what's the concept of the function to be even or odd algebraically. So I have a function f of x, and what I'm going to do is I'm going to replace my x with negative x. When I replace my x with negative x, the function does not change. If the function does not change, then that's an even function. Let me take an example of x squared. I'm going to replace my x with negative x, and then I'm going to square it. What's going to happen? You will get back the same function. You will get back the same function. Nothing changes. See, nothing changes. So that's an even function. What about an odd function? I take my function f of x, and I replace my x with negative x. And when I replace it, if the whole function becomes negative, then that is an odd function. My best example is x cubed. I am replacing my x with negative x, and I'm cubing it. What's happening? The whole function becomes negative. So if you look closely here, this is my x cubed. When I replace x with negative x, the whole function becomes negative. Now that's algebraically. Now let's go ahead and take a look here. It says determine whether the following functions are even, odd, or neither algebraically. Now you might say, Miss, do I have to do it algebraically? You don't have to. Just by looking at the function, you know that one power is, that here I have an odd power. I don't see a power. The power is 1. Two odd powers, the function is an odd function. But let's go ahead and work it out. What am I doing? I'm replacing my x with negative x. Do not forget the parentheses. Negative x. Now this gives me negative x cubed, and negative of negative makes it a positive. Now this one doesn't look like the function itself. But what am I going to do is I'm going to take out the negative sign, factor out the negative sign, and now I have x cubed minus x. Negative times positive is negative, negative times negative is positive, so I get back to the same function, right? So here, as you can see, this is my original function. Let me erase this one. This is my original function. When I replace my x with negative x, I get back the function with a negative sign. That's why it's an odd function. The whole function becomes negative. Now let's take a look at the next one. F of x is equal to 2x squared plus x power 4. Again, quick trick is to look at the powers. X squared, the power is 2, the power is 4. Both the powers are even, so the function is going to be even. Let's go ahead and work it out. 2, remember I'm replacing my x with negative x. Replacing my x with negative x. What happens? Negative x squared doesn't matter, becomes positive. Negative x power 4 is again x power 4. And now look what happened here. My whole function was 2x squared plus x power 4. When I replace my x with negative x, I got 2x x squared plus x power 4. So nothing changed. When nothing changes, the function is an even function. All right, now let's go ahead and take a look at the next problem here. Let me start with the powers. 2, even number. Don't see a power. I don't see a power. That means the power is 1. Wait a minute. 1 is even, 1 is odd. So what is the function? Neither even nor odd.